My name is Neve Zangi. I am from Edward R. Murrow High School, and today I will be telling you about how I created the optimum environment for seagrass growth. Seagrass doesn't look like much. You probably wouldn't be able to tell it apart from regular seaweed, but so many things in our environment rely on it every day. For one, it provides a habitat for hundreds of species, most of which are endangered, and it also fights against both climate change and ocean acidification by absorbing 83 million metric tons of carbon every year. That is the majority of our blue carbon. But despite its increasing importance for our future, its population is depleting 7% every year. If this trend continues, we will find ourselves closer and closer to irreversible climate change and ocean disaster. But there's a solution. I decided that I needed to find a way to create more seagrass, to grow more seagrass, to give ourselves a livable future. Pollution is the main problem attacking our seagrass, namely eutrophication, also known as nutrient pollution. Excess nitrate and phosphate suffocate seagrass, but duckweed, a common floating plant, loves it. Therefore, I decided to use this plant to maintain a healthy nitrate cycle in the environment. There's also a problem with heavy metal pollution, so I use sand filters to absorb that. Together, I hypothesized that my system will reduce pollutants in the environment and stimulate seagrass growth. The first thing I did was collect my water. I went to Coney Island Beach for my environmental sample and tested the water I found to find 1 ppm of phosphate and 5 ppm of nitrate. Then I made my contaminated sample by adding toxic amounts of nitrate, phosphate, and copper. I used sterile water for my control. Second, I made my filters using sand, gravel, and clay pebbles. I added the duckweed and the seagrass and took regular growth measurements for 2 weeks. After the trial, I compared the growth of all the samples. First, the control sample, which is the blue line on this graph, grew 1.1 centimeters. This is about the average growth for seagrass in our oceans. Then, my contaminated samples began growing after the first week. The sand filters and the duckweed needed time to absorb the pollutants, but after that, it grew 1.8 centimeters, greater than average. Finally, my environmental sample grew 4.8 centimeters, showing the best growth out of all the samples. The sand filter and the duckweed were able to work together to stimulate massive seagrass growth using the environmental water. I also tested the pollutants in the environmental and contaminated samples after the trial. Both experienced a 100% reduction in nutrients, and the contaminated sample experienced a 75% reduction in copper. These results support my hypothesis because both samples had a great reduction of pollutants and grew greater than the control. The environment I created is the best way to stimulate seagrass growth in all seagrass environments. It has shown to work amazingly well in the right circumstances and can still stimulate growth in heavily polluted ones. With my research, I know that we can protect our oceans and our climate through seagrass. Thank you for listening to my presentation today.